Welcome to a video on the statistical basics. In this video, we're going to look at some common terminology that's used as we study statistics. Let's get started. Let's start by looking at the definition of statistics itself. Statistics is a study of how to collect, organize, analyze, and interpret data collected from a group. There are two main branches of statistics: descriptive statistics, which focuses on how to collect and organize data, and inferential statistics, which relies on how we analyze and interpret data. To understand the difference between these two branches, let's take a look at the circle of statistics. Think of it as the circle of life. In statistics, we often start out wanting to know something about a population, but the population is usually too large for us to access. So we'll start by carving out a sample. Once we take a sample from our population, we'll then collect data from our sample. We use descriptive statistics to learn about our sample. Once we learn about our sample, we then want to use that information to make inferences about our population. So as we take that information and see how it applies back to our population, this is known as inferential statistics. Since inferential statistics is based on sample data, taking our sample from our population is a critical step to make sure we have reliable results. So taking our sample from our population is very critical. In fact, later on we'll study different sampling techniques that we can use to ensure that we have a representative sample from our population. Let's see how we convert data to knowledge. To do any statistical study, you need to know two things. You need to know who you want to study and what you want to study. In statistics, the who is known as the individual. This is the person or object you're interested in finding out information about. The what is known as the variable. This is a measurement or an observation of the individual. Taken together, the who and the what make up the population to be studied. The population is the set of all values of the variable for the entire group of individuals about which we are interested. Think of the population as all or whole. Let's take a look at some populations. Let's identify the individual and the variable for each population. The salaries for all U.S. senators. In this case, the individuals are the U.S. senators and the variables are the salaries for those senators. The ages for all students at a community college. The individuals are the students at a community college. The variable are the ages for those students. The software version for all operating iPhones. The individuals in this case are the operating iPhones. The variable is which software version. So it's important to note that the population is not just a group of individuals and it's not just a variable. It's the individuals and the variable together for a population. Let's take a look at some pros and cons of using a population. Pro is definitely that it's exact and accurate. Utilizing your population will yield some of the more accurate results. However, there is a downside of using the population. The economics. It's expensive to access your entire population. Every 10 years, the U.S. does a census where they try to access the entire population of people living in the United States. It takes the U.S. government a lot of money to try and estimate the entire size of the population. So it's very expensive. Speed, it takes a lot of time. When the U.S. government tries to conduct a census, it takes over a year to formulate a survey, collect the data, and tabulate the results. In some cases, it may be just impossible to access the entire population. When we can't access our population, we use our next best tool available, and that is a sample. A sample is a subset from the population. Ideally, it looks just like the population, but contains less data. Remember, stay tuned for a future video where we will learn good sampling techniques to ensure you have a representative sample. Just like the population, there are pros and cons to using a sample. On the positive side, it's less expensive. Dealing with the sample is just cheaper because there are less individuals compared to the population. It takes less time and it's very adaptable. There are different methods for finding a sample depending on what you're studying. There are some cons of using a sample as well. Inaccuracy. There will always be some discrepancy between a sample and a population. And there's variability. Information will vary from sample to sample. Because we distinguish between a population and a sample in statistics, we use parameters and statistics to denote information that's coming from a population versus a sample. A parameter is a number, like an average or percentage, calculated from the population. In statistics, parameters are usually denoted with a Greek letter like mu or sigma. More importantly, this number is a fixed and typically unknown number that you want to find. Our goal in statistics is to find or estimate the parameters. Now, a statistic is a number, like an average or percentage, but it's calculated from the sample. It's usually denoted with letters from the Latin alphabet. These will be things like X bar, S, P hat, or Y hat. Since you could find samples, a statistic is readily known, though it changes depending on the samples taken. And most importantly, a statistic is used to estimate the parameter value. Let's look at a few examples to determine if the information being given is a parameter or a statistic. According to a recent article, Twitter users have an average of 208 followers. We want to know, is 208, is that a parameter or a statistic? To determine that, you need to look at where this information is coming from. According to the information that we have, if this article is saying that Twitter users have an average of 208 followers, this information is from all Twitter users. If it's from all, then it's about the population. And if it's about the population, then it's considered to be a parameter. Let's look at another example. A survey of 40 randomly selected Twitter users found that the users had an average of 156 followers. We want to know, is 156 a parameter or a statistic? To do this, we need to look at where this information is coming from. In this case, we're told that this information comes from a survey of 40 randomly selected Twitter users. So this information is from a sample. So this information is a statistic. So parameters come from the population, statistics come from the samples. So if you're trying to determine is it a parameter or a statistic, look at who it's coming from or who it's about. Before we look at our last example, let's recap some of the key terms we've looked at so far. An individual is a person or object that you're interested in finding out more information about. The variable is the measurement or observation of the individual. The population is the set of all values of the variable from the entire group of individuals about which we are interested in. So remember, the population includes both the individual and the variable. The sample is a subset of the population. It should look just like the population but contain less data. A parameter is a number calculated from the population, and a statistic is a number calculated from the sample. So oftentimes a lot of these terms seem very redundant to students, and they are. Some of these terms describe the population and some describe the sample. Since there is a difference between a population and a sample, it's very important that we are clear when we tell the reader that this information came from the entire population or a subset. In our last example, let's identify the individual, variable, population, sample, parameter, and statistic from the following statement. The U.S. Census Bureau needs to estimate the median income of males in the U.S. They collect data from 2,500 males. The individuals in this case would be males in the U.S. The variable is their income. The population is a set of incomes of all males in the U.S. A sample would be the set of incomes from the 2,500 males in the U.S. So notice here, the population and sample sound very similar. They include both the variable and the individual. The difference is essentially how many people are in the group. The population includes all. The sample is a smaller group, only the 2,500 males. The parameter would be the median income for all males in the U.S. whereas a statistic would be the median income for 2,500 males in the US. So things can sound very redundant here in statistics, but the main thing to get across is that the redundancy is because we're just trying to be clear, did this information come from the population or from a sample? That's it for this video. Thanks for watching.